Welcome to FARO training. The topic I will cover today is filtering scan points in Scene 5.0. Before watching this video, it is recommended that you have watched the FARO video series Views, Selection, and Navigation, or at least have a good idea of how to use a planar view and select points. By the end of this tutorial, you should be able to identify the different types of filters, identify how each filter manipulates points, and be able to apply filters to scan data in Scene. The first topic we will cover is why we filter scan data, and then I'll talk about what can cause inaccuracies. Next we'll go through each type of filter and why you would choose a particular one, and then we'll switch to Scene to show how to actually apply it. So, why we filter points? Out of the millions of points captured by the scanner, most will have a good accuracy, but some will return incorrect values for a variety of reasons. We filter the scans in order to remove or correct points that are not really representative of reality. Here are some of the common causes of noise in the scan. Dust or moisture in the air, such as if it's drizzling or raining, will end up giving you stray points as it will reflect or refract the laser beam. Ambient light will also have an effect. On a bright sunny day, you'll have a closer range and more noise in your scans. Vibration or movement around the scanner or in the scene will make objects fuzzy. Distance is also a factor. As you get further away from the scanner, the points will gradually get less accurate and will be more affected by passing through a greater volume of dust or moisture. The surface quality of objects being scanned is also important. Very shiny or very dark surfaces tend to cause problems. Shiny surfaces will reflect the laser light away instead of reflecting it back at the scanner. The faucet picture on the right is a great example of noise on a shiny object. Very dark surfaces will absorb more of the light rather than other surfaces, leaving less light to return to the scanner, and thus typically less accurate points. The best way to avoid noise is to avoid getting it in the first place. Some of the environmental factors we just discussed can be alleviated while scanning, or at least improved upon. Try to scan when there is less dust or moisture in the air, and try to scan under less bright conditions if it's possible, by scanning in the morning or in the evening or on a more overcast day. For vibration, try to be careful when setting up the scanner. Turn off any heavy machinery around and try to keep it out of the wind. For shiny surfaces, try to get as perpendicular to the surface as possible. The more acute the angle, the more light will reflect away instead of return. Also, try turning up the quality and the resolution and get a little closer to the object. Getting closer and having a high res and quality will help for dark surfaces also. If these things don't work or aren't possible, we will then turn to filtering. Edge effect is something you will almost always see in scan data. This happens when the laser line, which is not infinitely thin but has a certain diameter, lands on two different surfaces at one time, such as on the table and on the floor behind it. This would end up giving the average of the two values, so you'd have a point kind of in the middle there, which is really just a bad distance value for either surface. Here's an example of what edge effect looks like pre-filtering. It's sometimes described as looking like snow blowing off a roof. Different types of filters do different things. Depending on the cause of error, you can sometimes achieve more precise measurement results by applying a correction, but sometimes you need to remove the point fully. The four kinds of filters are dark scan points, distance-based, stray, and smooth. The dark scan point filter is very simple. It removes all points under a certain reflectance value. The reason we do this is because dark surfaces absorb light. Therefore, very little light is returned. If not enough light is returned, the measurements become less accurate. This filter is run by default, but you can turn it off or rerun it with a different value if you wish. This only works when scans are in black and white and not after they have been colorized. The distance-based filter. Points will tend to get less accurate as they get further away, and they pass through more environment that can introduce noise. If an area of an object to be scanned is covered by more than one scan, it makes sense to keep the points picked up by the closer scan position. You can run a distance-based filter to make this happen. It will simply delete points further away than a certain distance picked by you. Stray filter. This is where it gets a little more complicated. but it's very useful in many situations. It removes outliers and strays and is great for getting rid of edge effect. You can run it on a section of a scan or on a whole scan. So how this filter works. There is a grid size, a distance threshold, and an allocation threshold, which is a percentage, all of which you can set. The function will look at a point and then at the grid of points around it. We're looking at that grid from the perspective of the scanner. It'll then take a look at a thickness in front and behind of that grid of points. That's going to be the distance threshold. And it will compare your center point to the points around it. If at least the specified percentage of the points in the grid are within the distance threshold, the point stays. If not, it is deleted. So effectively, it makes any points that are just off by themselves get deleted. Here's the edge effect picture we saw before, and then the after picture showing the same part after the stray filter has been run on it. The smooth filter. Smooth filter operates in a similar way to the stray filter, but instead of deleting the point, it moves it to the average of the grid. If a point is outside of the distance threshold from the initial point, then the outlier will not be used in the calculation. This corrects for noise on a surface that is smooth in reality, but where environmental factors cause the points to be rough. It is best to avoid using it on areas of fine detail, instead sticking to smooth surfaces. Here is a before and after picture of a surface before the smooth filter was run and afterwards. And now moving on to scene. I'm going to open a planar view of one of my scans here. And I'm going to select an area of points, which are now lit up in yellow. I'll right-click inside the yellow area and go to Scan Points, Filter. Here's where you can see all 4 of those filters that we've talked about, where they're accessible. When you run them from here, they'll only run on that selected area of points you just made. With the stray filter, we have the grid size, distance threshold, and allocation threshold. There are some defaults in there, but you can tweak the numbers if you want. Be careful when you're tweaking, start conservative and work your way up, because eventually you'll get rid of more points than you actually wanted to. Distance base. You just put the minimum and the maximum distance, and that's from the perspective of the scanner. They'll keep everything in between and delete everything outside of it. Dark scan. Reflectance threshold. You can see the reflectance threshold of any point. You see the RF value, which is just down here. The RF values, usually 200 to 300 is pretty typical for this to get rid of dark points, but you can tweak that as you want. And it just deletes any that are darker and keeps all that are brighter. And the smooth one. This is where you can put in the grid size and the distance threshold. Remember, be careful when you select areas that you're going to do that. Pick just the same surface. Don't try and run it on a large area or something that's not meant to be smooth anyway. Like that tree. Now, the other places you can access these is by right-clicking on either the scan or the scan folder and going to Operations, Pre-Processing, Pre-Process Scans. Here you can run either a dark point filter or a stray filter. It's got the same fields we've seen before, but this just allows you to run it on a whole cluster or on a whole scan at once. And just hit OK to run it. The last place we'll look at is by going to Tools, Options, and then going to Default Filter. You can also run a dark filter and a stray filter from here. These are applied on the first time you load any scan into Scene. And these are usually really helpful, and I'd recommend leaving them run most of the time unless you've really played with them a lot and know what you want to get out of it. Because these will take out most of the edge effect and most of the completely bad dark points. So those run for you all the time, so you're always getting those. They're usually pretty good. So, in summary, we talked about why we apply filters, the causes of inaccuracy. We identified the different filters available and how they each manipulate the data. You should now be able to apply appropriate filters to scan data. Thank you very much and have a great day.